Hi there, welcome back to part 2 of the Measures of Center video. In this video we will look at calculating the mean of frequency distributions and frequency tables, so essentially anything dealing with grouped type of data. A survey is conducted to find out information about IQ scores of Delaware Tech employees. The results are as follows. So right here we identify this as a frequency distribution because we have class intervals. And anytime we have class intervals, one of the first steps before you try and calculate anything is to take a moment and plug in your midpoints. So to find each midpoint, if you recall from Chapter 2, you add your lower and upper bound together and divide by 2. So take 50 plus 69 and divide that result by 2 gives us 59.5. Repeat the process, 70 plus 89, divide that by 2. Gives us 79.5. 90 plus 109 divided by 2 is 99.5. And finish filling these out for the rest of your data. That should always be your before you go any further step. Next, think about what the formula for grouped means are, or grouped mean is. Remember, x bar, the mean, is equal to the sum of your midpoints times frequencies. Divide all of that by n. So what this tells me, we can use a column method to help us keep our order of operations organized here. So now that I have my midpoints, I'm going to create a column for deal with the numerator first. I have to take the sum of these products. Order of operations dictates that you have to add these together. That you have to multiply these together before you can add them all up. So I'm going to create a column for my midpoints times my frequencies. And what I'm doing here is in this column, I'm taking the number in my midpoint column and multiplying it by the number in my frequency column. So I'm going to go and multiply across. 59.5 times 3 gives me 178.5. 79.5 times 15 gives us 1,192.5. 99.5 times 22 is 2,189. We have 119.5 times 8 gives us 956. And last but not least, we have 139.5 times 2, which gives us 279. Now, after we've multiplied, the formula says go ahead and take the sum. So what I'm going to do here is create the total down at the bottom. The sum of that column is equal to add all of these up. That gives me 4,795. So at this point, we have the entire numerator of our formula. How do we calculate the sample size? Well, earlier we talked about if you have anything with frequency in it, then the size, in this case sample size, is the entire sum of the frequencies. It's because you have 3 people in this category, 15 in this category, so on and so forth. So if we add those up here, we find that we have a sample size of 50. So how do I calculate the mean of this distribution? Well, the mean of this distribution is equal to the sum of m times f, which is 4,795, divided by our sample size, which is 50. This gives us a mean of 95.9. So what does that imply about our data? Right? Our mean is somewhere in this central category, which, using your common sense, think about what that implies. The largest frequency, in other words, the modal class here, is also in that category. You'll see that our numbers start at 3, they move up a little bit, and then they taper back off. So it should make sense that our mean is also somewhere in this centralized number. If you calculate the median, it's also very likely that it's in this category. So one thing you can ask yourself is, does this make sense in context of data? If your answer is no, then you should revisit the problem. You should check over your work again. One thing I see very frequently is having a mean that is not within the boundaries here. So in terms of how can I check this over using my common sense? let's say I made a mistake and I only divided by, we have, let's say, 5 instead of 50. So let's say, what's 4795 divided by 5? Gives me 959. So let's just say we made a mistake. We didn't realize it yet, but that's the mean that we got. Could you have a mean IQ score of 959 when the highest IQ possible in this list is 149? Absolutely not. So make sure that you're being mindful of what makes sense in context. If you ever get feedback from me that says, does your result make sense? Is this actually possible? Chances are you made a fatal flaw, and it's something that you should pick up on because common sense dictates otherwise. So be wary of stuff like that. Make sure you're using what you already know. If a number does not seem right, it's very likely that something went wrong. Now, using this concept of group data, let's talk about what this would look like with a frequency table instead of dealing with these class intervals. It's actually a little simpler to calculate when dealing with a table because you already have your x values. In other words, those were the midpoints we calculated before. A survey is conducted to find out information regarding the number of children parents in Wilmington, Delaware have. The results follow. So right off the bat, we do not have class intervals here, but we do have frequencies. We can use the same weighted formula that we did before, but treat the number here, the number of each is a data item. Of course, you'll see this is discrete data this time. We're going to treat these like our midpoints. So just like we did before, I'm going to multiply my midpoint by frequency. So I have here 0 times 3, we have 0, 1 times 2 is 2, 24, 3, and 8. And that's the hardest part, because after that, it's just a matter of adding them up. Take the sum. The sum of this column is equal to, let's see, so we have here 26, 29, 37. So the sum of 37. And then to find n, we have to add up our frequencies. So n here is equal to, added up, we get 20. So essentially, what's this telling us? We took a sample of 20 parents in Wilmington, Delaware, and now we're about to find out what the mean number of children they have are. So to get our mean, that's equal to the sum of midpoints times frequency, which is 37, divided by 20, which gives us 1.85. So what does this imply, right? If I said to interpret the results, well, use our common sense for a second. Technically, the number of people is a discrete figure, so saying that the mean is 1.85 may not make sense. However, we could say that, according to this, the mean number of children people in Wilmington, Delaware have is somewhere between 1 and 2 children. So it's okay to say the mean is 1.85, but make sure you're backing that up with what does that actually mean in context. It's somewhere between 1 and 2 children. It's not 1.85 of a child, because you can't have 0.85 of a child. However, again, it's the idea that it's somewhere between those figures. So anytime you're asked to interpret, use your common sense to figure out what this type of question means. And I know I'm going to use the phrase, use your common sense often, and that's because you have to use what you know from your own background, from your own life, to put this information in context. It's not something that there is kind of a hard answer for, because you're interpreting what makes sense to you. Please stay tuned for the next part of this video, where we will explore measures of variation.